Assalamualaikum and greetings to all. Okay, welcome back. All right, let's continue with example 5. So here we're given, we have to evaluate this triple integrals by changing it to cylindrical coordinates first. So for cylindrical coordinates, we cannot have x and y. So this integrand x squared there will be replaced by r and theta. Okay, now if you recall for cylindrical coordinates, what we're going to do is we're going to project our solid G onto the xy plane. So the integration should be with respect to z first. The upper limit for z would be the top surface, and the lower limit for z is going to be the bottom surface. And this dA here will be r dr d theta. Now, if you compare the cylindrical coordinates with the Cartesian coordinates, where we project our solid onto the xy plane, now you can see that if you do that, the integration should be with respect to z first. So the upper limit for z is the top surface, and the lower limit for z is the bottom surface. Except now, so you can see that the upper and the lower limits for z are similar. It's the same as in cylindrical. So in cylindrical, we have the top surface would be the upper limit, the bottom surface would be the lower limit, except in cylindrical we don't use x and y, we use r and theta, and in Cartesian we use x and y. So the main thing that you need to remember here is the upper limit for z in Cartesian, the upper and the lower limits for z in Cartesian is the same as the upper and the lower limits for z in cylindrical. The difference is you don't use x and y, you use r and theta. And to change x and y in terms of r and theta, you just use this relationship between x and y with r and theta. Okay, now let's continue with our example here. So here you can see that the order of integration is with respect to z. So here that's the upper limit for z, and this is the lower limit for z. So the upper and the lower limit for z in Cartesian is the same as upper and lower limit for z in cylindrical, except you don't use x and y. Okay, all right, so here we can straight away, okay, I'm going to write this as r on the xy plane. So the upper limit for z, well, first the integrand. So x squared, that's the integrand. That will be replaced by r and theta. And if you recall, for x, it's equal to r cos theta. So we're going to change that. So x squared will be replaced by r cos theta squared. Okay. And dz is still dz. But here, dy dx is considered as dA. So in cylindrical, that would be r dr d theta. Okay. Now let's get the upper and lower limits for z. So upper limit for z here is 4. So that's the top surface. So in cylindrical, it's the same thing. It's still 4. So still the top surface. And the lower limit is x squared plus y squared. So in cylindrical, that will still be the lower limit for z. But you don't use x and y. So we have to change to r and theta. So in here, we have x squared plus y squared is r squared. So in our example here, this will be, so x squared plus y squared will be replaced by r squared. Okay, so now we need to get the limits for r and theta. So the limits for r and theta can be obtained by looking at the region r. Okay, so here we have our region r, okay, which is on the xy plane. So to do that, we need to use the limits for x and y. So here we have the upper and lower limits for x and y. So we can come up with the 4 equations. From the 4 equations, we can sketch our region r, and then from there we can get the limits for r and theta. Okay, all right, so here we have 0 and 2. 0 and 2 are the limits for x, so we can come up with the 2 equations. So we have x equals 2, that is from the upper limit of x, and we have x equals 0, that is from the lower limit of x. And here we have upper and lower limits for y. So we have another 4 equations. Upper limit for y is 4 minus x squared, square root of that, and lower limit is y equals to 0. Now we can sketch the 4 equations. The 4 equations is going to be, well, some of you can do this very quickly. sorry. Okay, so here we need to sketch the region R by using the upper and the lower limits for x and y. Okay, for x, we have x equals 2 and x equals 0, so that's easy. X equals 0 is just the y-axis, okay, y-axis, and x equals 2 is just the vertical line. Okay, we have x equals 2. Now let's concentrate on the upper and lower limits for y. Here you have the upper limit for y is positive root, meaning that y is positive. But if you can't sketch the equation, you can always do some manipulation. So in this case, I'm going to get rid of the square root. So we're going to square both sides. So we have y squared on the left, and on the right we have 4 minus x squared. Rewrite the equation, then you can see that this is an equation of a circle of radius 2 centering at 0, 0, the origin. But refer back to the original upper limit of y, it's y positive, meaning that we only take the top half of the circle where y is positive. Okay, so we have a circle of radius 2 centering at 0, 0. So let's sketch the half of the circle. So here we have half of a circle, and the lower limit is y equals 0. Then remember we have x0 and x2, so from there we can get our region R, which is a quarter of a circle. Okay, and the equation of the circle here, we can rewrite this using r and theta. So x squared plus y squared is r squared, and on the right we have 4. So rewriting that, we get r is equal to 2. So the equation of the circle here, another name for the circle, is r equals 2. Okay, all right, now we can get the limits for r and theta just by referring the region R, which is, as you can see, it's a quarter of a circle. So rewriting this, I'm going to write this as r cubed cos squared theta dz dr d theta. Z is from r squared to 4. Okay, now let's get the limit for r and theta. Okay, let's get the limits for theta first. So remember, you measure theta from the positive x-axis anti-clockwise direction. Then you can see that it starts on the x-axis positive, so it starts from 0, and then it stops on the positive y-axis where theta is pi over 2. And for r, you draw a straight line from the origin across your region. Then you can see that it starts at the origin, so it's 0, and then it stops on the red circle, which is governed by this equation. So r is from 0 to 2. Okay, now once you have the limits for r, theta, and z, I'm sure you have no problem evaluating this, but let's do this together. Okay, so here we have 0 to pi over 2, 0 to 2. Now the inner integration is with respect to z. Let me write this in red. Okay, so here we're going to integrate this with respect to z, which means that we consider r and theta as constant. So we have r, oops, sorry. Okay, so we have r cubed cos squared theta considered as constant, and then integrate with respect to z. So we have z here. Upper limit for z is 4, lower limit is r squared. Okay, replacing r with replacing z with upper and lower limits, then we get 4 minus r squared. Okay, I need more room. I'm gonna copy this to the next page. Okay, now next we're going to integrate the middle integration, but before that I'm gonna simplify the integrand first. I'm gonna put cos square out, and here we have 4r cubed minus r to the power of 5. Oops, dr d theta. Let me erase this. Okay, all right, now integrate. The next is integration with respect to r. Okay, so cos square theta will remain as cos square theta because we consider theta as constant when we integrate with respect to r. So here we have r to the power 4 over 4, but 4 over 4 is 1. And here we have r to the power 6 over 6, and then replace r with upper and lower limits. Okay, so replacing r with upper and lower limits, we get 4 to the power 4 is 16. 2 to the power 6 is 64. Okay, now simplify that. Okay, let me see. 16 minus 64 over 6 is 16 over 3. Okay, I'm going to put it here. Okay, now to integrate cos square theta, we're going to use the trigonometric identity, where cos square theta will be replaced by cos 2 theta plus 1 over 2. So this would be easier to integrate. All right, now 16 over 3 divided by 2 will give you 8 over 3. Okay, now integrate cos 2 theta, we get cos 2 theta over 2, sorry, sine 2 theta over 2. Integrate 1, we get theta. And then replace theta with upper and lower limits. Okay, replacing theta with pi over 2, we get sine pi. Sine pi is 0. Okay, and then minus the lower limit. Well, sine 0 is 0. So we get pi over 2 there. So that will give us 4 pi over 3. So right? Yeah. Okay. All right. So let's recap. Upper limit for z. So if you're given cylindrical, if you're given Cartesian integration, triple integral, you want to change it to cylindrical. If the inner integration is with respect to z first, so the upper limit for z is going to be the same in cylindrical. The lower limit for z is also the same as in cylindrical, except you don't use x and y, change it to r and theta. So you don't have to sketch the solid G. You only need to sketch region R by using the upper and lower limits of R, x and y. So from there you can get the limits for r and theta. Okay, that's it. Thank you.